Okay, in this video we're going to talk about vectors. What is a vector? A vector is a quantity that has both a size and a direction. That's a vector. And so a typical vector would be, for instance, a velocity vector, right? So the velocity vector is this vector here. And so the size of this vector would be what? 5 meters per second. And the direction would be this direction, and it points in that direction. So that vector that vector has two pieces of information, if you will. It has the speed, and it has the information that tells you where you're going. So that is a vector, and vectors are very useful in physics. And we are going to in this video, we're going to show a few tricks on how to deal with these vectors and do some mathematical manipulations with it. So there is also the idea of a scalar. A scalar is a quantity that has only a magnitude. For instance, the temperature. The temperature doesn't have a direction, but the velocity, so scalar, has only a magnitude. For instance, the temperature. A velocity is a vector, and when we denote vectors, when we write them, we're going to put an arrow like this. In the book, you're going to see them written in bold as symbols, right? So we're going to say that two vectors are equal, and this is our definition of vectors. Two vectors are equal if they have the same magnitude and the same direction. For instance, here we have this vector and this vector, so we are going to say that they are equal. By that we mean they represent the same physical quantities. So the first thing we want to do with vector is we want to learn to do addition. We want to have two vectors, and we want to know what is the vector c, which is equal to the vector a plus the vector v. So in order to do that, so we would have to come up with a new trick. So imagine that this is your vector a, right? And this is your vector v. So what is a vector c? Well, we're going to say the vector addition is a vector that goes from this point to this point here. It's this vector here. And this is equivalent to saying that this is your initial displacement. Then you go from here to here, so this is your second displacement. What is your total displacement? Well, it would be the vector that goes from here to here. One thing that you can see is that this is, it doesn't matter the order, right? So a plus b is equal to b plus a. So then we call these ways to add vectors. We give them names. One is the tip-to-tail rule or the parallelogram rule. So basically, if you want to add two vectors, for instance, you have vector d and vector e, you go from the tip here to the tail here. So the vector addition is this vector that goes from tip to tail. Another way to do that is that you take this vector e and you move it all the way here. That is e, right, until you get this picture. And then you go from here to here. This is a parallelogram, right? And this is the parallelogram vector addition. So multiplication by scalar. So when we have vectors, we can change the length of the vector. How do we do that? Well, we multiply by scalar. For instance, if we want to double the length of a, we just multiply here by a 2. So, and then you get a vector that is twice as long. So if we multiply by 0, we get a vector that is called the 0 vector. So a vector cannot have a negative magnitude. It's going to have a length, right? But it can point in what you call the negative direction. That is different, and you need to make sure that you understand that the difference between having a negative magnitude, which is something that it cannot happen, and pointing in the negative direction. So for instance, these two vectors here, they have the same magnitude, right? They have the same length, but one is the negative of the other. This vector here is negative, right? It's a negative vector that points in the negative direction, or in the negative sense of A, but it has a positive magnitude, where it's 3 times the magnitude of A. So how do we, another thing that we need to do is subtract vectors. How do we do that? This is a tricky one, but the way we're going to think of that is A minus B is going to be equal to adding this, right? So all we need to do is change the direction of B. So let's say you have vector A here, vector B here. What is A minus B? Well, it's this vector plus the negative of B, which is that vector. So this is the negative of B, right? And the vector subtraction is that vector that goes there, which is this. This is A minus B. So when we have vectors, we sometimes want to draw them in a coordinate system. That makes it very easy to do general manipulation of vectors. So we are going to use in this class what is called the Cartesian coordinate system, which is 2 axes, x and y, that are perpendicular to each other. This is 90 degrees. And this point here, this is called 0, is your origin of the axis. So in this coordinate system, then we can break the vector into components. So a vector has components, and components are just these other vectors that point in the direction of the axis. And when you add these two, you get your original vector. So here you have AX is component X and AY is component Y. So that's the definition of vector components. And what we can see is that this is going to be very useful later on when we want to deal with motion in 2 dimensions. So let's say you have a vector A and you want to find the components of that vector A. So, well, let's say you know the magnitude of the vector, which is denoted like this, right? So what is the component AX? What is the magnitude of this component, right? So for that, we are going to need this angle here. So then we need to figure out what this component is using this angle. So a trick to do that is going to be shown to you when we do some trigonometry. But let's just do a little example here of components. So we have A, right? So A can be broken into this component plus this component. So the component here is the magnitude of AX is 3 here, and this one is 2. Here you have B, and B can be broken into this component and this component. This has a magnitude of 2 and this has a magnitude of 2, but this points in the negative direction. So this component is minus 2. So this component is 2 and this is minus 2. Although this doesn't mean that this has a negative magnitude, it means that this component points in the negative direction of the x-axis. So how do we find the components of a vector? We use trigonometry. Let's say we have this vector here and we want to find this component here and we know this angle here. Well, we can use trigonometry and say that AX, which is this length here, is A cosine theta. And the component, that's the component along the x-axis, and the component along the y-axis would be sine theta A sine theta, so that's the component here. So here you would have this vector AX, here you would have this vector AY, and the magnitude of these two vectors are given by these trigonometry relationships. So now that we know if we have the components, so how do we go back and find the magnitude of a vector? So then you would use Pythagoras, right? So you want to find this length here, and this is a right triangle. So this length is equal to this one squared plus this one squared. So this one is ax, this one is ay. So ax squared plus ay squared is equal to the square root of that is equal to the magnitude. And if you use the tangent, then you can find the angle. So let's look at a little more detail on how we can add vectors using components. So now you know how to find the components. How do you add the vectors? Well, that's pretty easy. All you need to do is just you find the components of the first vector, you find the components of the second vector. So the first vector has this component and this component. The second vector has this component and this component. And then you can see that all you need to do is add the components. So that makes addition really, really easy. So C, which is your vector addition, has component Cx, which is ax plus bx, and Cy, which is component ay plus by. So if you have more than two vectors, then all you need to do is add the components. No, so it doesn't matter how many vectors you have there. So important places where you're going to be using this is when you have forces, and we don't know what a force is yet, but we'll get to that later. But for now, imagine that a force is an important quantity in physics that can be described by a vector, right? So then a force can be broken into many forces, right? So you have here a normal force, a weight, a friction force, and each one of these can be broken into components. And then you would have a force for the x-axis and a force for the y-axis, and that's going to be a place where vectors are going to become very important. Another important place where vectors are going to be of use is when you have things like inclined planes, right? So if you have an object here that is moving this way, how do you study that? Well, the easiest way to study that is to set what is called a tilted coordinate system, tilted axis, right? Like this one here. And then what you can do now is you can use the vectors in this tilted coordinate system to study the motion of this object here. So let's look at that example in more detail. So we have an object, a car that is going up a hill here, right? So we know this angle here, that is theta. So we have the initial position, x and y. So now we need two coordinates for the initial position, and we have the time, and we have a final position here, and we have the time, and we have the velocity. So now the velocity vector is this guy here, and the velocity vector is a 2D vector now, right? That has two components. It has a component in the x direction, vx, and a component in the y direction, vy. So you can see that all our physical quantities, v, delta x, and a, now become vectors. And they have two components. They have vx, vy, delta xx, and delta yy, and delta and a has ax, ay. And typically when we have more than two components, what we are going to do is call this r. And so this would be a vector with vx, vy, two components. This would be a vector with x, y, and this would be a vector with x, ax, ay.